1,200%. That is not a performance target. That is not an aspirational budget line. In April 2026, the United States Department of Defense submitted a procurement request to Congress for fiscal year 2027. The line item for the BGM-109 Tomahawk Land Attack Missile showed a requested production increase of 1,200% over the established baseline. Defense analysts who had spent careers reading Pentagon acquisition documents said publicly, and more specifically off the record, that they had never seen a multiplier like that outside of a declared wartime mobilization. One former Undersecretary of Defense for Acquisition described the number as a flare. Not a procurement request, a flare. The kind you fire when you want to be seen. This is not a story about a missile. It is a story about what happens when the world's most powerful Navy runs 9 months of sustained combat operations and discovers, in the mathematics of the aftermath, that it has exposed a strategic vulnerability it spent 3 decades of procurement strategy designing against. A vulnerability that is not classified, visible to every intelligence service with access to congressional testimony and a basic understanding of industrial production rates. A vulnerability that the People's Liberation Army Navy has been wargaming for years. Here is the math. The BGM-109 Tomahawk Land Attack Missile is the United States Navy's primary standoff precision strike weapon. Range: 1,000 nautical miles in the baseline Block 4 configuration, extended further in the Block 5 variant. Guidance: GPS-aided inertial navigation layered with terrain contour matching, and a terminal image guidance option for mobile targets. Warhead: a 1,000-pound blast fragmentation device with penetrator capability against hardened structures. Unit cost in fiscal year 2024 procurement: approximately $2.1 million per missile. It is, by design, a weapon you fire from safety. A Burke-class destroyer deploys with 96 vertical launch system cells, a mix of SM-2 surface-to-air missiles, SM-6 extended-range interceptors, evolved Sea Sparrow missiles, and Tomahawks. The ship never approaches the target. The missile does the flying. That is the foundational logic of standoff precision strike. You reach inside an adversary's integrated air defense system without exposing the platform that launched you. For 9 months, beginning in the summer of 2025, the United States Navy did exactly that. The strikes began in the Red Sea theater, Houthi ballistic missile launch sites in western Yemen, radar complexes near Hodeidah and along the Tihama coastal plain, weapons storage facilities carved into hillsides in Saada Governorate, underground preparation areas that intelligence had assessed as hardened ballistic missile assembly and fueling sites, precisely the infrastructure that enabled Houthi forces to threaten commercial shipping lanes and U.S. Navy surface combatants operating under Operation Prosperity Guardian. Then the campaign expanded into the Persian Gulf, Iranian Revolutionary Guard Corps naval infrastructure at bases along the northern Gulf Coast, coastal surveillance radar installations on Abu Musa Island and on the Greater and Lesser Tombs, the disputed islands sitting directly across the approach lanes into the Strait of Hormuz, fuel and logistics depots assessed as supporting IRGC fast attack boat swarm operations, hardened communications relay nodes that the National Security Agency had been mapping for years, nodes that tied together the IRGC's distributed maritime surveillance network. Then the Eastern Mediterranean opened a third operational arc. Precision strikes against Hezbollah weapons storage and logistics infrastructure in eastern Syria and in the Bekaa Valley, coordinated with broader CENTCOM operations that had been in the planning cycle longer than the public timeline suggested. Each strike package consumed Tomahawks, not dozens across a weekend, hundreds over cycles. Sustained, recurring, replacing degraded targets as adversaries rebuilt and reconstituted, requiring restrike decisions that compounded the consumption rate. Here is the number that reached congressional staff in partially redacted logistics summaries. By the end of 9 months of sustained operations, the United States Navy had fired more Tomahawk Land Attack Missiles than in any comparable operational period since the opening 72 hours of Operation Iraqi Freedom in March 2003. And here is the problem embedded in that number. The Navy did not have a warehouse with unlimited replacements waiting to be loaded. To understand why that matters, you need to understand how Tomahawk production actually works, and how it was allowed to reach the state it was in when the operational tempo of 2025 began. Working through the procurement history and the acquisition reform documents from the past 2 decades, one detail kept surfacing in ways public reporting consistently underemphasized. The Tomahawk production line has never been designed as a high-volume manufacturing operation. This is a precision weapon with approximately 3,700 individual components. It contains a Williams International F415 turbofan engine. It contains a GPS receiver integrated with a terrain-following guidance computer. It contains a 1,000-pound warhead with selective fuse options. It is assembled, tested, and certified at a single facility. Raytheon's production plant in Tucson, Arizona. One plant, one assembly line, one location where completed Tomahawk missiles enter the U.S. Navy inventory. Before the operational surge of 2025, that facility ran at a production rate calibrated for peacetime inventory replacement and modest operational consumption. The established baseline was approximately 500 missiles per year. 500 missiles per year. Run the attrition equation against 9 months of 3 theater sustained operations. The arithmetic does not require classified data to produce a troubling result. Even at conservative estimates of consumption per operational cycle, strike packages measured in the dozens per major operation, restrike requirements against reconstituted targets, theater reserve requirements that rules of engagement and operational planning standards require be maintained. The gap between what the production line was producing and what the operations were consuming was significant. That gap does not close by writing a larger check to Raytheon. It closes by rebuilding a manufacturing infrastructure that had been allowed across 2 decades of defense budget cycles optimized for counterterrorism and irregular warfare to narrow toward minimum viable production. The Tomahawk was the right weapon for the missions it was given. The industrial base behind the weapon had not been sized for the mission tempo the weapon was actually required to sustain. There is something worth naming directly about how this happened. The strategic logic of standoff precision strike was never seriously questioned in the years between 2003 and 2021. The Tomahawk performed in every operational environment it was used in: Iraq, Afghanistan, Libya, Syria. The weapon worked, but the procurement cycles that followed each use were calibrated to peacetime replacement logic. No one in the acquisition system decided that standoff strike was so central to every plausible major combat scenario that the production base needed to be maintained at surge capacity. The weapon's reliability became, paradoxically, an argument for not overinvesting in its industrial base. This was not a failure of individual decisions. It was a failure of the framework within which those decisions were made. The acquisition system is designed to prevent wasteful overprocurement. It performed that function correctly. What it did not account for was the possibility that the same weapon would be needed simultaneously in 3 theaters against 3 different adversary sets, and that the consumption rate would create a strategic exposure in the one theater where the risk calculation was most consequential. The obstacle was not operational, it was structural, and structural problems do not reveal themselves until the structure is actually loaded. Here is what made the structural problem genuinely dangerous, rather than merely embarrassing. Every Tomahawk fired at a Houthi radar installation in Yemen was a missile drawn from an inventory that serves more than one theater of operations. That inventory also serves the Pacific. Run the attrition equation for a Taiwan contingency scenario. In DOPACOM, planning documents that have appeared in unclassified academic literature and in congressional testimony established the parameters in general terms. A major combat scenario in the Taiwan Strait would require precision strike inventory at rates measured in thousands of weapons in the first weeks of high-intensity operations. Forward deployed surface combatants, attack submarines, the full strike capacity of multiple carrier strike groups operating against hardened People's Liberation Army coastal defense infrastructure, airfield targets, and PLA Navy surface forces attempting to enforce a blockade. Every Tomahawk that went into a Yemen hillside or an IRGC coastal facility was one fewer Tomahawk in that Taiwan contingency reserve. PLA Navy operational planning staffs noticed. This is not a speculative claim. It is a function of how military intelligence analysis works. When a peer competitor's precision munitions inventory draws down at scale, visibly in congressional testimony, in procurement filings, in the documented production rates of a publicly traded defense contractor, you update your models. You revise your cost-benefit calculation for a confrontation you have been planning for years. You look at the timeline. The question is not whether PLA analysts ran that calculation. The question is what conclusion they drew from it. The procurement request was submitted, the flare went up. And in the same weeks that the April 2026 filing reached congressional defense committees, something happened at Raytheon's facility in Tucson that had not happened in more than 20 years. The plant moved to triple shift production, 3 shifts, 24 hours a day, 7 days a week, additional workers hired, suppliers put on accelerated delivery contracts, subcomponent timelines compressed wherever the physical capacity of the supply chain permitted compression. The bottleneck processes that had set the baseline production ceiling, specific circuit board assembly workflows, a turbofan subcomponent machined at a single-source facility in Ohio, were targeted for parallel capacity expansion alongside the Tucson ramp. Here is the counterintuitive part of the production response, and it matters for understanding what the Pentagon actually believed about the timeline. The Department of Defense did not wait for congressional approval of the FY 2027 budget before beginning the production surge. Emergency authority under existing appropriations law permitted the initiation of the ramp-up before the new fiscal year funding was authorized. The 1,200% procurement request filed with Congress in April 2026 was not a projection of what might happen if the request were approved. It was documentation of a decision already executed, already running, already committed. The congressional filing was the paperwork catching up to the operational decision. When a bureaucracy that moves on annual budget cycles invokes emergency authority to begin spending before the budget is authorized, it is telling you something about how it has assessed the urgency. The filing is the signal. The production ramp is the response. Together, they tell you that someone at the decision level made a judgment that the standard timeline was incompatible with the actual risk. The visible production response was one half of the answer. The less visible half happened at sea, and it revealed a second structural problem that the Tomahawk burn rate had exposed. In the first quarter of 2026, Indo-Pacific Command began a series of at-sea exercises described in public affairs releases as cross-deck vertical replenishment operations. The name is bureaucratically neutral. The capability it represents is not. A Burke-class destroyer carrying Tomahawks in its vertical launch system enters a high-tempo strike campaign and fires. The cells empty. In the traditional operating model, the ship withdraws from the operational area, transits to a logistics port, Bahrain, Diego Garcia, Guam, takes on replacement missiles, and returns to station. That transit and reload cycle takes days. In a sustained, high-intensity Pacific conflict against an adversary whose entire doctrine is built around targeting U.S. logistics nodes and supply chains, those days represent vulnerability. The port represents a target. The transit represents an absence from the fight. Cross-deck replenishment at sea removes the port from the equation. Missiles delivered by vertical replenishment helicopter or transferred ship to ship at sea under operational conditions mean the combatant does not have to leave the fight to rearm. The concept existed. The equipment existed in prototype and partial deployment. The procedure was written. The training had been conducted sporadically. What it had not been was certified at operational scale, with the full range of hull types, sea states, and munitions variants involved in an actual Pacific contingency. What made the certification harder than it sounds on paper is the physical reality of the weapon. A Tomahawk and its launch canister weighs approximately 2,000 pounds. Moving a 2,000-pound precision missile from the deck of a logistics ship to the vertical launch cells of a destroyer at sea without damaging the missile, without damaging the ship, and without injuring the personnel doing the transfer requires specialized handling equipment, a detailed weight and balance certification, and personnel who have practiced the evolution enough times under realistic conditions to execute it reliably. The obstacle was infrastructure and repetition. INDOPACOM's 2026 exercise series addressed both. The frequency, the number of ships involved, the integration with TAKE underway replenishment vessels. All of it pointed to a command converting a theoretical capability into an operational one on a deliberate timeline. What matters most about the cross-deck certification program is not that it happened, but that it happened in parallel with the Guam Reserve reallocation decision. Because those two actions, taken together, reveal a strategic judgment more significant than either decision individually. The munitions pre-positioned at Naval Base Guam, stockpiles held in hardened storage as a Pacific contingency reserve, began shifting toward forward-deployed surface combatants in the Western Pacific, not emptying Guam entirely, not removing the reserve function, but incrementally redistributing inventory toward the ships that would be in the fight first if a Taiwan scenario opened. The logic is straightforward once you state it. A missile in hardened storage on Guam is survivable during peacetime. It is also, in the first hours of a peer conflict against an adversary with DF-26 anti-ship ballistic missiles and a well-mapped understanding of Guam's basing infrastructure. A missile that might not survive long enough to reach the fight. A missile already loaded in the vertical launch system of a destroyer operating west of the first island chain is in the fight the moment the order is given. INDOPACOM made the judgment that forward operational availability outweighed pre-conflict storage survivability. That is a real trade-off. It is also a statement about how the command has assessed the likelihood and timeline of the scenario it is preparing for. Here is the part that does not sit right, even now. The Guam reallocation and the cross-deck certification were both responses to the inventory problem revealed by CENTCOM operational tempo. But the targeting decisions that drove that tempo, the choices about which target categories justified Tomahawk expenditure, were not systematically reviewed until the inventory problem had already become severe enough to require emergency procurement authority. The after-action summaries from carrier strike group operations in the Red Sea and Persian Gulf, working from what is available in declassified and partially redacted form, show a specific pattern worth examining directly. Not all Tomahawks achieve equivalent operational value per missile fired. A missile that destroys a hardened ballistic missile storage facility, permanently eliminating the weapons stored there. High operational value per expenditure. A missile that destroys a coastal radar installation that the adversary reconstitutes using pre-positioned replacement equipment within 6 weeks. Lower value per expenditure, compounded when the restrike decision consumes a second missile against the same target type. The after-action data shows that a significant category of targets struck during the 9-month campaign fell into the second type. Targets that were hardened, redundant by design, or rapidly repairable using pre-staged components consumed disproportionate shares of the inventory because the initial strike achieved temporary suppression rather than permanent destruction. The pattern was visible in the operational data from the 3rd month of the campaign. The question this raises, and it is a genuinely uncomfortable one, is whether the strike decisions that drove the inventory drawdown were calibrated against both their immediate tactical effect and their strategic cost in terms of Pacific deterrence capacity. Here is the take that will probably get some pushback. The answer based on the pace of the procurement response and the emergency authority invocation, is that the Pacific cost calculation arrived late. The individual strike decisions were tactically defensible. The cumulative strategic cost was not fully integrated into the operational decision framework in real time. That is a system failure, not a personnel failure. But the distinction matters less than the consequence, and the consequence is a 1,200% emergency procurement request filed in April 2026. Would you have made the same targeting calls if you knew each Tomahawk fired reduced the Taiwan deterrence reserve by 1 unit? Drop yes or no in the comments. That is the actual strategic equation buried in the procurement documents. Now, the full system equation. Before the operational surge of 2025, the United States Tomahawk inventory, across all platforms, all commands, all storage facilities, was assessed by outside defense analysts at somewhere between 4,000 and 6,000 missiles total. The actual number is classified. The range established in public analyses is sufficient to understand what the math of the 1,200% procurement request implies. A 1,200% surge over a baseline of 500 missiles per year means approximately 6,500 missiles requested for fiscal year 2027. At $2.1 million per missile, that is approximately $13.65 billion in Tomahawk procurement for a single fiscal year. For reference, the entire U.S. Navy shipbuilding budget for fiscal year 2024 was approximately $32 billion. A single weapon procurement request representing more than 40% of annual shipbuilding funding. That number does not appear in peacetime procurement. That is the financial signature of an emergency replenishment on a war economy timeline. When PLA Navy planners ran their own analysis of the combined picture, the operational consumption data visible in congressional testimony, the emergency procurement filing, the Raytheon triple shift announcement, the cross-deck certification exercises, the Guam reallocation signals, they were not looking at a weakness in the abstract. They were looking at a window with potentially calculable dimensions. PLA doctrine for a Taiwan scenario has, since at least the early 2000s, included a phase designed around attrition of U.S. precision strike capacity. The underlying logic: if the U.S. Navy fires its Tomahawk inventory against PLA coastal defenses in the early days of a conflict, and the consumption rate exceeds the resupply rate, the U.S. progressively loses the standoff capability that allows it to strike inside PLA integrated air defenses without platform risk. The Navy either fires standoff missiles until the magazine runs low, or it sends the platforms closer. Closer means within range of DF-21D and DF-26 anti-ship ballistic missiles. That is the exchange Beijing has been engineering toward. The 9 months of CENTCOM operations did not break the U.S. Navy. They did not achieve that. What they did was give Beijing's planners a real-world data point they had previously had to model from assumptions. The actual Tomahawk consumption rate at sustained operational tempo in a 3-theater environment, compared against the production rate that had been publicly documented for the Tucson facility. The gap between consumption and production in the real-world data of 2025 to 2026 was larger than the most aggressive PLA planning models had assumed. The production ramp is running. The cross-deck certification is advancing. The Guam redistribution is underway. 3 parallel responses to a single underlying problem. But none of those responses directly addresses the targeting efficiency problem identified in the after-action analysis, which suggests that the consumption rate, if CENTCOM operational tempo continues at 2025 levels, may outpace the production ramp before the inventory is restored to the level required to fully resource a Pacific contingency. That is the calculation being worked at classified levels. It does not have a public answer. What it has is a set of decision points approaching on a timeline that Raytheon's Tucson production schedule makes visible in approximate terms. One detail that stayed with me throughout this analysis: the triple shift decision at Tucson was authorized not by a procurement bureaucracy running its normal cycle, but by an emergency authority invocation that bypassed the standard approval timeline. Someone made that call. Someone at the decision level looked at the inventory figures and the operational consumption projections and the Pacific timeline, and decided that the standard acquisition process was not compatible with the actual risk. That person, whoever they were, was looking at the same math that PLE planners were running from the other side. The emergency authority invocation is the American acknowledgement that the window concern is real. The production ramp will run. The inventory will recover. The question the procurement filing cannot answer, and the question every strategic planner in Washington and Beijing is working, is whether the recovery completes before Beijing assesses the window as optimal. Here is what this moment in the procurement cycle tells us about the strategic era we are in. The United States built a doctrine around standoff precision strike. The weapons that doctrine depends on are made at one facility, at a production rate calibrated for peacetime, drawing on supply chains that were never hardened for surge. When the doctrine was tested at sustained operational tempo across 3 theaters simultaneously, the industrial infrastructure beneath it revealed its limits. The weapons worked. The strategy functioned tactically. The system failed logistically. The 1,200% request is the acknowledgement of that failure in numerical form. 1,200% is not an aspiration. It is a calculation. Someone ran the numbers on consumption, projected the trajectory, compared it against the Taiwan contingency requirement, and came up with a number that would restore the margin. If production holds, if the supply chain scales, if CENTCOM tempo stabilizes enough to allow the inventory gap to close. Every one of those conditions is uncertain. The Strait of Hormuz is partly open. The Red Sea is contested. The Pacific deterrence requirement has not changed. Raytheon's Tucson plant is running around the clock for the first time in 20 years. And the math is still running. Will the production surge close the gap before the strategic window opens? Drop stockpile in the comments, because what we just showed you is the equation the Pentagon is racing against, and the outcome of that race is going to matter more than any single strike mission conducted in the past 9 months. Subscribe to Navy Strike Force. We do not celebrate weapons. We calculate whether they work. And right now, the most important calculation is not happening in a targeting cell in Bahrain. It is happening on a factory floor in Tucson, Arizona, one shift at a time.